Welcome to lecture 13 of Advanced Database Management System. In this lecture, we will be covering about query performance optimization. Query performance optimization is useful in the bigger systems and bigger softwares. If you are having a small software, you may not be doing query performance optimization because a simple web app or a small database that has simple front end may not be actually showing any issues if it has few users. But bigger systems such as banking, financial transactions, or anywhere where you're doing reporting and dashboard, all sorts of querying could lead to lags and delays if your queries are not optimized. Okay, so query performance optimization relates to schema optimization, indexing, which are necessary for high performance of databases. They are automatically done when you are creating the tables, when you are creating your structure. But this is not enough because you also need to design your queries well, and queries are generally coming from the database, from applications. So why are queries slow in the first place? So queries are slow because it takes a lot of time for them to execute. You see, so the queries are slow for two reasons. And if you are asked these questions in the exam, make sure you are able to explain this way. Queries are slow because it's about response time. It takes time for the queries to respond. Secondly, all the queries are also tasks. So each task has multiple subtasks, and those subtasks consume time. So addition of all those response times together creates a bigger response time. So generally speaking, is one point about response time. Okay, to optimize a query, you must first optimize those subtasks or eliminate them, make them happen fewer times, or make them happen more quickly, and you will see examples as we follow through. Execution is one of the important stages in a query lifetime. It involves a lot of calls to the storage engine to retrieve rows, as well as after those items have been retrieved, what we know as the post-retrieval operations. Grouping, sorting, query spends a lot of time on these things as well. So if you do grouping at the end of the query, or sorting, ascending, descending order, or alphabetical order, the query spends a lot of time on doing that. Another important thing is if your query is relating to a server, on the network, that will also take time due to the network speed, due to the network congestion, delays in the network itself. If that is not taken into account, even if that is not taken into account, just because it is the network not directly connected to you, means it has to create a socket and go and deliver the information through the protocol stack, and it takes time in the CPU depending on the CPU time. Other things such as statistics and planning, lock-in, these things also take time, and when we say take time, we are talking about few milliseconds rather. However, adding all those times together could create an issue for bigger systems. In every case, excessive time may be consumed because the operations are performed needlessly. It may be too many operations that you are doing in the query. What is optimized data access? So a query doesn't perform very well because it's working with too much data, basically speaking, and most bad queries can be changed by accessing less data than needed. Number one, how to optimize a query. Number one, for example, find out whether your applications is retrieving more data than you need. That usually means it's accessing too many rows, but it might also be accessing too many columns. You see, if your table is very big, it may be accessing too many columns. Find out whether the DBMS server is analyzing more rows than it needs. Meaning, on the DBMS side, on the DBMS side, if you have too many columns being accessed, right? If you say select star, for example, what you actually need is just the name and the salary column only, but you are saying select star, for example. Or in other case, for example, you are just looking for the first 5 rows, or even if you are trying to display the whole table, you may paginate them. Why not paginate them? 10 rows per query, or 20 per query, instead of getting all the rows at once, which would slow down the query and even slow down the applications. Okay, case number 1, are you the one who's asking for too much data? Let's analyze this case. So some queries ask for more data than you need, so you can actually analyze that and correct it. Some of the issues that come across these things because of a query: you are fetching more rows than needed, or fetching all columns from a multi-table join. If you select star here and select star there for 2 tables, for example, or you are fetching all the columns, or you have already queried something and you are querying that again and again, while you know this is read-only data that may not be modified for a longer time. Why do you want to read them again and again? These are examples of things that could actually create slower queries. For example, names of the islands, or atoll names, an example, country names of the world. Such things, if you are trying to access every now and then from the database, what's the point? While you know that those things will not change unless the world changes. So certain things can be hard-coded, or certain things can be statically defined as a list, or periodically looked up. Okay, what does it mean to fetch more rows than needed? For example, assuming that the DBMS provides the results on demand, such as issuing a select statement that returns many rows, then fetching the first n rows and closing the results. For example, fetching the 100 most recent articles for a news site, when they only need to show 10 of the most recent on the front page. So that's an example where you are actually trying to retrieve more data than you need. So the best solution is to add a limit to the query. At the end of the query, you can just place a limit if you're looking for a specific amount. So if you are not looking for the whole data, limit the data you query from the database. Another type of information you have to remember is fetching all the columns from a multi-table join. You see, if you say select star and then you're doing inner join with other tables as well, you are retrieving everything from 1, 2, 3 tables in this case, for example. So it is important for you to limit your query by identifying exactly what it is that you're looking for. So instead of star, what are the things you're looking for? Give the details of the columns you're looking for. So as you can see from here, an example, instead of saying select star, you can give select this table dot this, or this table star if it is not much, or this table dot actor name, this table dot field name. So you don't have to be retrieving everything on other tables, especially on the tables that refers to a foreign key, because you are trying to use that foreign key and look up something, not look up everything on the table. So that is an example. Fetching all the columns, some comments about that one. You should always be suspicious when you select star. Retrieving all the columns can prevent optimization, such as covering indexes as well as adding input, output, memory and CPU overhead. Asking for more data than you really need is always bad. Some bottom line you have to keep in your mind. It might also be useful to retrieve more data than you actually need if you use some type of caching in your application. If it may be useful, or if you have another benefit in mind, of course, that may be useful. For example, you may retrieve the data and not request for more in the future. Meaning, if you have just because you have requested more, allows you to keep them and handle them and use them in the future. So fetching and caching full objects might be referable to running many separate queries that retrieve only parts of the object. So you could actually cache objects to solve the problem, unless these are items that change so frequently. What about fetching the same data repeatedly? As I said, some data you are looking up, a database field, for example, is populated using data. That may be an example where you may actually see an issue. You don't want to look up the same data again and again every time the user goes to edit page, for example. Every time the user goes to delete page, you are trying to show something. Why are you querying the whole table there? That may be an example of a situation where you could avoid that. So writing application code that retrieves the same data repeatedly from the database server, executing the same query to fetch this. Just read only queries, but you're trying to read too many times. This may be one issue. And again, depending on your network speed, this could slow down the whole application itself. For example, if you want to find out a user's profile image URL, for profile images URL, you're trying to display the profile image of the user and you're trying to query the URL only, you might request this repeatedly for each comment. See, that's one example where you might actually see, if you have a forum where the user is commenting and all his comments, you're looking up his URL from the database. That's one way to do it, of course. But you could cache it the first time you fetch it and reuse it thereafter, unless the user has changed his image, meaning right now if the user is in the session and he has not modified his data, why are you fetching it every now and then? So don't fetch the same data repeatedly. That is another important thing. Okay, that is from the user perspective. What about the DBMS perspective? Maybe from the DBMS perspective, it is doing too much work, which is why it's very slow. So some of the example of query metrics include response time that it takes to get a response, number of rows you are examining, from those rows, number of rows returned. These are all added into the query optimization matrices. So reflect roughly how much data the DBMS must access internally to execute a query and translate approximately into how fast the query runs. Okay, that will give you some idea of how fast the query runs. For example, response time. What is response time? Response time is the sum of two things: service time and queue time. Again, two more definitions here, remember to learn them. Service time is how long it takes the server to actually process the query. Queue time is the proportion of response time during which the server isn't really executing the query. It's waiting for something, such as waiting for an input-output operation to complete, or waiting for a lock, or so forth. Okay, so those are important things that could contribute to the delay. Number of rows examined. Is it examining too many rows? Not all rows are equal. Shorter rows and faster rows. Shorter rows are faster to access because they have less columns, and fetching rows from memory is much faster than reading them from the disk. Okay, so some databases may actually fetch it after loading it to the memory. For example, when constructing rows with joins, the server must access multiple rows to generate each row in the result set. Especially joins could be slow. So when constructing rows with joins, the server must access multiple rows to generate each row in the result set. This is why even DBMS might be slow. Okay, how do you restructure queries? You could do many queries, or you could do one complex query. Which is better? You see, it's always preferable to break up a complex query into several simple queries. Sometimes you can make a query more efficient by decomposing it and executing a few simple queries instead of one complex one, because it accesses less data or because it accesses data differently. In this case, we can say you are chopping up a query. So you could actually divide the query into several pieces, getting the same result but in a different way. For example, chopping up the delete statement and using medium-sized queries can improve performance considerably and reduce replications, like when a query is replaced. When a query is replicated. If you look at this one, for example, delete from messages where create date is less than 3 months from the subscription compared to now current date, so past 3 months. Okay, so you are trying to delete a lot here, but look at the next solution. Deleting 1000 rows at a time is a large enough task that make each query efficient and short enough to minimize the impact on the server. So instead of deleting everything together, of course, as I said, if the application is small, it doesn't really matter, but you could actually get the web services slowed down because of huge queries. So you have to make sure on the front end especially that you handle the data and show the user proper responses. Instead of deleting everything from the server, you could continuously delete 1000 at a time. Okay, and yeah, doing the query continuously by setting rows affected equal to 0 as the beginning item in the loop. And some sleep time between the delete statements to spread the load over the entire over time and reduce the amount of time locks are held. You could add some sleep time between the delete statements. Or you can do join decomposition. Instead of one big join query, you can select items slowly using variables, putting the items into the variables and then running them separately. Although one query can list for you many things, it may not be the best efficient way to retrieve those data. So example, this query can be decomposed as below. An example, 4 different queries can be done if you know the variable names. Okay, restructuring can actually give significant performance advantages if you restructure the query. First, executing the query individually can sometimes reduce log contention. Doing join in the application makes it easier to scale the database by placing tables on different servers. You can reduce redundant row accessing. Doing a join in the application means you retrieve each row only once, whereas a join in the query is essentially denormalization that might repeatedly access the same data. Query execution basics. What happens when you send a SQL query? The client sends the SQL query to the server. The server checks the query, caches the query. If there is a hit, it returns the stored result from the cache. Otherwise, it passes the SQL statement to the next step. If the server process reprocesses and optimizes the SQL into a query execution plan, then it is kept in the execution query plan. The query execution engine executes the plan by making calls to storage engine API. The server sends the results to the client. So there are 5 steps of what happens to the query as it enters the query and leaves the server. So important for you to read and make sure you remember a little bit of these steps. Okay. So basically, these are ideas that will trigger in your mind a little bit of why we run through data like this, why we run through lectures like this in order to teach you about query optimization, because as I said, if you have a small application you may not actually see that. In bigger enterprise applications, especially if your application is designed for enterprise, you will see your clients complain about this, because either your application is accessing too much data or the database is spending more time because of the way the database has been designed. It takes too much time to access the data, or it does too much work trying to retrieve your data. So both of these work together, and you have to make sure that your programs are well written so that query has been optimized. Okay, so that's it for this lecture. Thank you very much, and in the next class we will be covering about more details of another topics, especially database security. Okay, see you guys in the next class.